What's up, my dear students? It's NARESH BABU. Welcome back to Physics Crash. Students, in this session, I'm going to discuss about NEET previous year questions from dual nature of radiation and matter. Let us start the game. Dual nature of radiation, NEET previous year questions. Here the first question. An electron is accelerated through a potential difference of 10,000 volt. Its de Broglie wavelength is given mass of electron 9 into 10 power minus 31 kg. It was given in 2019. So here the options. Option A 12.2 into 10 power minus 13 meter. Option B 12.2 into 10 power minus 12 meter. Option C 12.2 into 10 power minus 14 meter. And option D 12.2 nanometer. Solution. Given potential difference is equal to 10,000 volt. So we have formula for de Broglie wavelength in terms of potential difference, that is lambda is equal to root over 150 by V Armstrong. So that is equal to root over 150 by V means 10,000 volt into Armstrong means 10 power minus 10 meter. So I can write approximately root over, instead of 150, 144 I will write. Why? Because root over 144 I know that is 12. So for easy calculation I am taking approximate value here. So instead of 150 I wrote 144. So here root over 144 by 10,000 means 10 power 4 into 10 power minus 10 meter. So if I simplify, I will get 12.2 into 10 power minus 12 meter. From the given options, option B is the answer. Now we will go with second question. Here the second question. An electron is accelerated from rest through a potential difference of V volt. If the de Broglie wavelength of the electron is 1.227 into 10 power minus 2 nanometer, the potential difference is, it was given in 2020. Here the options. Option A 10 volt, option B 10 power 2 volt, option C 10 power 3 volt, option D 10 power 4 volt. Solution. Given potential difference is equal to V volt and de Broglie wavelength lambda is equal to 1.227 into 10 power minus 2 nanometer. So if you simplify in terms of nano, if you substitute 10 power minus 9 and if you simplify, you will get 1.227 into 10 power minus 11 meter. So we have the formula from de Broglie wavelength in terms of potential, that is lambda is equal to root over 150 by V Armstrong. So that already we know in previous problem, that is if you simplify this root over 150 by V Armstrong, then you can write 12.27 Armstrong by root over V. So from the above step we can write root over potential, that is root over V is equal to 12.27 Armstrong by de Broglie wavelength. So now 12.27 as it is I will write in terms in the place of Armstrong I will write 10 power minus 10 meter by de Broglie wavelength given 1.227 into 10 power minus 11 meter. So I substituted de Broglie wavelength here. Then if I simplify, here I will get 10 power 2. So here we have to find potential difference. So if I do squaring on both sides, then I will get V is equal to 10 power 4 volt. So I got potential difference 10 power 4 volt. So from the given options, option D is the answer. Now we will go with third question. Here the third question. Light of frequency 1.5 times the threshold frequency is incident on a photosensitive material. What will be the photoelectric current if the frequency is halved and intensity is doubled? It was given in 2020. So here the options. Option A doubled, option B 4 times, option C 1/4 and option D 0. Solution. Given frequency, that is initial frequency, nu1 is equal to 1.5 times of threshold frequency, that is equal to 3.2 threshold frequency. So and also given frequency is halved, intensity is doubled, what will be the photoelectric current? That means nu2 frequency become halved. So we can write nu2 is equal to nu1 by 2. So here in the place of nu1, if you substitute 3 by 2, nu naught by 2 already there, so we will get 3 by 4 nu naught. That means nu2 is less than nu naught. That means nu2 is less than threshold frequency. So no photoelectric current takes place. So here the value of photoelectric current will be 0. So option D is the answer. Now we will go with fourth question. Here the fourth question. An electromagnetic wave of wavelength lambda is incident on a photosensitive surface of negligible work function. If m mass is of photoelectron emitted from the surface has de Broglie wavelength lambda suffix d, then it was given in 2021. So here we have options in terms of given wavelength and de Broglie wavelength. So from the given options we have to choose appropriate answer, either it is in terms of given wavelength or in terms of de Broglie wavelength. So solution. From Einstein equation we know that hc by lambda is equal to maximum kinetic energy plus work function. So here from above step we got hc by lambda is equal to maximum kinetic energy. Since here work function is negligible, why? Because in the problem they have given that is negligible work function. So it is equation 1. Given for mass m of photoelectron has de Broglie wavelength lambda suffix d. So we know the formula for de Broglie wavelength in terms of maximum kinetic energy, that is lambda suffix d is equal to h by root over 2m into k max, that is maximum kinetic energy. So if I do squaring on both sides, I will get lambda d square is equal to h square by 2m k max. So from that k max is equal to h square by 2m lambda suffix d square. So kinetic energy maximum value from equation 1 we have hc by lambda. So in the place of maximum ke I substituted hc by lambda, since from equation 1 we substituted that. So from the above step we got wavelength of electromagnetic wave is equal to bracket of 2mc by h into lambda suffix d square. So we got the answer here from the given options. Option C is the answer, my dear. That's about this session. I hope you like this session. If you like it, share it and subscribe it, and have fun. Bye students.